Hello again. We're still using products minus reactants here to find the delta H's for mystery reactions, and this time they're getting us to write the reactions. So we have methanol, wood alcohol, the one you definitely shouldn't drink, reacting with oxygen, and like most burning hydrocarbons, that gives us carbon dioxide and normally I'd say steam because this is forming in a flame and so it's going to be vaporized, but they say we're in a sealed container, the water ends up liquid, so liquid it is. Now, before you can do products minus reactants, you need not just a reaction but a balanced reaction because we use those coefficients, remember. So let's see if we can balance this. One carbon, good. 4 hydrogen, need a 2 there to balance that. Keep that as is. And now for oxygen, we have 2 oxygens here, 2 more oxygens here, total of 4. On the left, we have 1 oxygen there, so to make our total, we'd need 3 oxygens here. You could put a 3 over 2 here, if you don't mind fractions. You could put a 1.5 here, or if fractions bug you, you could multiply the entire reaction by 2, and you'd end up getting 2, 3, 2, 4. Let's do that, just so we don't have fractions inside of our brackets. 2, 3, 2, 4. Quick check, 2 carbons, yes. 4 hydrogen, I'm sorry, 4 inside times 2 is 8 hydrogen, and 8, that's good. And then here we have 4 oxygens plus 4 more oxygens, total of 8. Here we have 2 oxygens plus 6 more here, total of 8, so everything's balanced out. Now we have a reaction we can use to find our delta H. Delta H equals products minus reactants, or right side minus left side. 2CO2 plus 4H2O. Water's listed twice in the book, so make sure you note that it's liquid. Don't use the steam number. 2CH3OH, that's methanol, and 3 oxygens. 2 times carbon dioxide is minus 393.5, plus 4 times liquid water is minus 285.8, minus 2 times methanol, starts with M, where is it? Methanol is minus 239.2. And oxygens are zeros. 3 times 0 is still 0, so no one cares about that. And now we calculate. 2 times minus 393.5 plus 4 times minus 285.8. You can put this in as is, or if you're comfortable with it, you can cancel those two signs and just say plus 2 times 239.2. And I get minus 1,451.8 kilojoules. We're not done. We're not done because they asked for the molar enthalpy of combustion for methanol, and that means this number should be kilojoules per mole. To get that last little step, to make this molar, we have to take this number, which is for this reaction, which means, this is important, it's for 2 moles of methanol. So our molar delta H, or what they sometimes call delta HM, would be minus 1,451.8 kilojoules for every 2 moles of methanol. Divide that out and you get, what is that, 725.9 kilojoules per mole. Mental math is dangerous. I better check that. 1451.8 divided by 2. Yes. So that's the molar enthalpy of combustion for methanol. Products minus reactants, and if they had just said the enthalpy of combustion or find the delta H for this reaction, we could have stopped here. But when they say molar, then giving them just kilojoules is not good enough. You have to take your kilojoules and divide it by moles of the appropriate thing. Here they said enthalpy of combustion for methanol, so we went and got the coefficient for methanol, and that's where this last step came from. Good.